I'm explaining how the LassoLarsIC model selects the best model parameters. We'll unpack what LassoLarsIC does and how it uses criteria like BIC. It's a method for finding the best balance between model accuracy and complexity. Think of it like Goldilocks looking for the just right porridge. I'm evaluating statement A, which says LassoLarsIC gives you the best alpha regularization strength value directly. This is incorrect. LassoLarsIC finds the best alpha indirectly by calculating many alphas and comparing the BIC Bayesian information criterion for each. It's a search for the best alpha. I'm focusing on statement B. It's correct. The criterion attribute of the fitted LassoLarsIC model holds all the BIC values calculated for every alpha value tested. Think of it like a report card showing how good each alpha performed. Statement C claims LassoLarsIC only checks a specific list of alpha values. This is wrong. LassoLarsIC actually tries a asterisk range of alpha values. It explores many different options to find the most suitable one. It's more like a continuous search rather than a discrete list. Statement D is saying that the coa_ attribute, which holds the model's coefficients, reflects the coefficients for the alpha minimizing the AIC, AICA information criterion. This is false. It actually displays the coefficients for the alpha minimizing the chosen criterion, which, in this case, is BIC, not AIC. I see that statement D claims the LassoLarsIC model's coa_ attribute shows coefficients for the alpha value that gives the lowest AIC, AICA information criterion. But that's wrong. The coa_ attribute actually gives you the coefficients for the alpha value producing the lowest BIC, Bayesian information criterion. Because I used criterion equals BIC, when I trained the model. Remember, we set the criterion to BIC, so the model will use BIC for selection. This statement is absolutely correct. The criterion attribute of the LassoLarsIC model directly stores all the BIC values calculated for every alpha value the model tested during training. This is super useful because we can see how BIC changed with each alpha. Statement A is false. LassoLarsIC doesn't explicitly give us the optimal alpha value. Instead, it implicitly identifies the best alpha. The one associated with the lowest BIC value is what we're interested in. We can find the associated alpha using other attributes. This is incorrect. LassoLarsIC doesn't use a fixed set of alphas. Instead, it uses a path algorithm. It explores a range of alpha values to find the sweet spot for minimizing the selected information criterion, either AIC or BIC. I'm using LassoLarsIC, a scikit-learn tool, to pick the best model for a linear regression problem. It uses a clever algorithm called least angle regression, LARS, to find the ideal balance between accuracy and simplicity. LassoLarsIC's criterion attribute is a treasure trove. It holds all the Bayesian information criterion, BIC, values. Each BIC value corresponds to a different amount of regularization strength, alpha. I use these BIC values to find the alpha that gives me the best model. The BIC values are numbers that tell me how good each model is. A lower BIC means a better model. Each BIC is calculated using an alpha value. We choose the model with the lowest BIC. These are the numbers that tell me the impact of each feature in my final, chosen model. They're the weights that LassoLarsIC assigns to each feature, reflecting its importance in predicting the outcome. These coefficients are related to the alpha value that gives us the best BIC. LassoLarsIC doesn't explicitly tell me the best alpha. Instead, it implicitly uses the alpha that gives the lowest BIC. It's like finding the lowest point on a curve. We know it's there, but we may not know its exact coordinate. I've specified that I want LassoLarsIC to use the Bayesian information criterion, BIC, to select the best model from all the models it creates with different alphas. LassoLarsIC doesn't test a few set alphas. Instead, it explores a wide range of alpha values. Think of it as systematically searching for the optimal regularization strength, like a tiny scientist meticulously adjusting a dial. I'm working with a dataset that has 100 observations, samples, and 5 features, variables, to explain each observation. I use this dataset to train my LassoLarsIC model. I'm using LassoLarsIC, a scikit-learn tool, to pick the best model for a linear regression problem. It uses a clever method to find the optimal balance between the accuracy of the model and its complexity. LassoLarsIC doesn't use a preset list of alpha values. Instead, it explores many different values of alpha, each representing a different level of regularization strength, to find the one that yields the best model. Think of alpha as a knob. Higher values shrink the model's coefficients more aggressively, creating a simpler model, and lower values allow more complex models. After finding the best alpha, based on the BIC, LassoLarsIC calculates the coefficients for each feature in your model. These coefficients are what determine the impact of each feature on the final prediction. They are a key part of the model itself. I've set the criterion to BIC, which stands for Bayesian Information Criterion. This is a metric that helps LassoLarsIC decide which alpha value leads to the best model by considering both the model's goodness of fit and its complexity, preventing overfitting. I'm working with a dataset containing 100 data points, samples, each described by 5 different characteristics, features. For each alpha value explored, I compute the BIC. LassoLarsIC stores all these BIC values in the criterion attribute, allowing me to trace how the model performance changes as I vary the regularization strength. The best model will correspond to the lowest BIC value. I'm using LassoLarsIC, a scikit-learn tool that helps me pick the best model for linear regression. It uses the least angle regression, LARS, algorithm and considers either IC or BIC to choose the optimal model. LassoLarsIC stands for Lasso Least Angle Regression with Information Criterion. LARS is a clever algorithm for fitting linear regression models, especially effective with many features. AIC stands for Akaika Information Criterion and BIC stands for Bayesian Information Criterion. Both help you find the right balance between a model that's accurate on the training data and a model that's not overly complex and might overfit. I specifically told LassoLarsIC to use the Bayesian Information Criterion, BIC, to judge which model is best. Remember, lower BIC values mean better models. LassoLarsIC doesn't use a fixed set of alpha values. Instead, it intelligently explores a range of alpha values. Alpha controls the strength of the regularization, how much the model shrinks the coefficients, the numbers that show the importance of each feature. A larger alpha means stronger shrinkage. For each alpha value it tries, LassoLarsIC calculates the BIC. I'll get a list of BIC values, one for each alpha value. These show how well each model with a particular alpha fits the data. Once LassoLarsIC finds the best model, the one with the lowest BIC, I get the coefficients. These coefficients show how much each feature contributes to the prediction, their importance in the model. LassoLarsIC doesn't explicitly give me the best alpha value. Instead, I implicitly know it because the model coefficients correspond to the alpha that gave me the lowest BIC. It's like it points towards the winner but doesn't explicitly name it. I'm using LassoLarsIC, a scikit-learn tool that helps me choose the best model for a linear regression problem. It uses the least angle regression, LARS, algorithm and considers the Bayesian Information Criterion, BIC, to find the optimal balance between model fit and complexity. It's like having a smart assistant to pick the best option from many possibilities. I specifically tell LassoLarsIC to use the Bayesian Information Criterion, BIC, to evaluate models. BIC helps me select the model that best explains the data without being overly complex, penalizing models with more parameters. It's a number that indicates how well a model fits and its complexity. A lower BIC is better. LassoLarsIC doesn't use a fixed set of values. It explores a range of alpha values. Alpha is a tuning parameter. It's like a dial controlling how much I shrink the model's parameters, aiming to prevent overfitting. A higher alpha leads to more shrinkage and a simpler model. I'll find the best value during the exploration. It's clever, it automatically finds the best range to explore. For each alpha value LassoLarsIC explores, it calculates a corresponding BIC value. This shows me how good the model is for that alpha. I'll use these to find the optimal alpha. After exploring the range of alphas and calculating many BIC values, I identify the minimum BIC which corresponds to the best model. Once I've found the best alpha, the one that gave the minimum BIC, I get the coefficients. These coefficients are the parameters of my best fitting model. I use LassoLarsIC, a scikit-learn tool, to select the best model for my linear regression. It cleverly uses the least angle regression, LARS, algorithm to find the best fit while managing complexity using either AIC or BIC. I've chosen to use the Bayesian information criterion, BIC, to help me select the optimal model. BIC helps balance how well the model fits the data with how complex it is. A lower BIC score is better. I calculate the BIC for various amounts of regularization strength, alpha values. This helps find the sweet spot where the model fits well without being overly complex. Each alpha represents a different level of constraint on my model's coefficients. I find the alpha value associated with the lowest BIC score. This identifies the model that best balances accuracy and simplicity, according to the BIC. I retrieve the coefficients of the predictors for the model corresponding to the best alpha, minimum BIC. These coefficients define the relationship between the predictors and the response variable for my best model. I do not use a fixed set of alpha values. Instead, I explore a wide range to find the best one. LassoLarsIC determines which alpha values to test through an iterative process, not a predetermined list. I store all the BIC values calculated for each alpha in the criterion attribute. This helps me see the full BIC path, allowing me to select the best alpha. This attribute is vital for making informed model selection decisions.